let's talk about a half fraction of a 2 by 2 factorial. So I have factor A and factor B, each with 2 levels. That makes 4 different possible combinations, but for sake of illustration and argument, let's suppose that I'm only going to collect data from 2 out of 4 of those possible combinations. So here's a figure that shows a full factorial layout, shows the 4 possible combinations. And let's think about what it would do, or how I would collect data from basically 2 out of 4 of those corners. For sake of illustration, let's start there. Let's suppose that I collect data from factor A at its low level, factor B at its low level. What then is my only obvious choice for where to collect data for a second combination? If I were to choose to collect data from combination A, that means that both of my 2 process setups would be done at the low level of factor B, and I will learn then nothing about what happens when I turn the B knob from low to high. So the point is that this is not really a viable option if I'm going to use both factors at their low level, if I'm going to use combination 1. The same argument says that collecting data from combination B, that is A low, B high, gives me no information on what factor A does when I change its level. So if I was going to choose 2 out of 4 of these combinations to collect data for a half of a 2 to the 2 factorial, it would have to be those 2. Now if I started not by considering 1, this combination down here in this lower left corner, but I'd started with either A or B, I would have highlighted in yellow the other diagonal. But the point here is that whether I use this combination and this one, or the 2 green ones, what I'm going to do is to collect data from one setup and then change both the setting on the A knob and the setting on the B knob. That is, I will either use these 2, or I will choose the green 2 and collect data at those 2 combinations. Now think about what that will leave me with if indeed I see a big change in a response. If, for example, when I go from here to there, I see a big change in Y, what does that mean? If I see a big change in Y, is it because I changed the level of A? Is it because I changed the level of B? Or is it because there's some kind of an interaction between A and B? You see, I'm going to be left with an ambiguous result because I didn't pay for all 4 corners of that full 2 to the 2 factorial. The point is that there's going to be some ambiguity that's inevitable. And there's just no way around it, because I didn't pay for, I'm talking about looking at half of 2 squared is 4 combinations. And that's the nature of fractional factorial experimentation. So this paragraph just writes out carefully what I've just illustrated in that discussion.